Today's topic is effects of sound wave. I hope you all are watching the lectures from the classes and having a good understanding of the topics. So today's lecture is obviously linked to the lectures above of sound waves. Topic sound. The frequency of a sound wave is related to its pitch. The frequency of the sound wave, two keywords are given here, frequency and the other keyword is pitch. The frequency of the sound wave is related to its pitch. So basically the sound with high pitch, those sound have a high frequency. Those sound have a high frequency. So if you change it the opposite way, low pitch will have a low frequency. Low pitch will have a low frequency. I hope that's clear. Moving to the second point, when we talk about the amplitude, the two keywords given here are amplitude and volume. Amplitude and volume. So basically if I make a note that sounds which have larger amplitude, they have a high volume. They have high volume. What do they have? They have high volume. Then if I turn it the opposite way, sounds which have smaller amplitude, they have low volume. Okay, moving forward, there are some diagrams shown here. The first structure here is explaining you that this is a low volume sound, but this thing here is indicating the amplitude. How do you measure the amplitude? This is the amplitude. So comparing these two images, image 1 and image 2, which picture do you think has a larger amplitude? This one has a larger amplitude. Okay, so here it's smaller amplitude and here it's larger amplitude. I hope this is clear. So if it has larger amplitude, which means it will have high volume or low volume? It will have high volume. A high volume. This red arrow shows the indication of the amplitude. When we move forward, again we have two diagrams. This is a low pitch sound. How do you know this is a low pitch sound? Because it has low frequency. So if there is low frequency, which means it will have low pitch. If the pitch is low, the frequency will also be low. Now when we are comparing these two diagrams, this is a low pitch, this is low frequency. If you're comparing this diagram, this will be a high pitch sound. How do you know this is a high pitch sound? Because there is high frequency. More number of frequencies equals to high frequency. Is that clear? Now match it. High frequency, high pitch. Low frequency, low pitch. I hope that is clear to you. Moving forward, another subtopic we have is echo? What is it? Echo. What basically is echo? Sound waves reflect off hard surfaces. Sound waves, they're reflecting hard surfaces. So basically the reflection of a sound wave, I'll write it here, the reflection of a sound wave, the reflection of a sound wave is called an echo. It's called an echo. Echo soundings can be used to measure the depth or to detect objects which are under the water. They are the objects which are under the water. 2 points here I have written. This is point number 1. This is point number 2. That a sound wave can be transmitted from the surface of the water. A sound wave can be transmitted from the surface of the water. The sound wave is reflected off the bottom of the ocean. The reflection of the sound wave, where does the reflection of the sound waves takes place? Where does the reflection of the sound wave takes place? It takes place from of the bottom of the ocean, like from the bottom, from the deepest part of the ocean. Okay, so when we are measuring the echo, there are certain formulas and there are certain quantities which needs to be taken. So basically, if you're taking the time taken it takes for the sound wave, what I was speaking about, the time it takes for the sound wave to return is used to calculate the depth of the water. How can you calculate the depth of the water? By measuring the time taken it is used to return. Okay, I hope that is really clear. The other subtopic which we have is ultrasound. What is that topic? That topic is ultrasound. That topic is ultrasound. The humans, they have a frequency, they have a limit. The humans can hear the sound between, what is the range? Between 20 hertz and 20,000 hertz. 20 hertz, 20,000 hertz in frequency. This is their hearing range. This is the hearing range for humans. All right. What is ultrasound? When we speak about ultrasound is nothing but anything above the range of 20,000 hertz. Anything above the frequency of ultrasound is anything above the frequency of 20,000 hertz. That thing is called as ultrasound. When we speak about the uses of ultrasound, okay, when ultrasound reaches a boundary between two media, some of the waves are partially reflected. Ultrasound transducers are able to, I can write it down here. Actually, no, forget it. I will note down the points because then it will be easier for you guys to note down. Ultrasound transducers are able to do what? They are able to do what? First thing is they are able to emit ultrasound. If they are emitting the ultrasound, obviously they will also receive the ultrasound. They will also receive the ultrasound. The formula to calculate the speed, distance, and the time equation in ultrasound is average speed. Average speed is equal to distance moved divided by what? Divided by the time taken. Divided by the time taken. You also use ultrasound in medicine industry. In the medicine industry, you can use ultrasound. It can be used to construct images of a potus in the worm. It can generate 2D images. It can generate 2D images of the organs. All these nodes will be provided to you. And ultrasound is also used for a medical treatment when you're removing kidney stones. You use the technology of ultrasound. So all the nodes will be given to you. Please have a look at the notes, and soon we will be starting with the past paper classes of this topic. Don't forget to like, share, and subscribe the channel for more lectures.